Hey everyone! So today we're going to look at a few exercises on recursion. We will do exercises 1, 2, 12, 22, and 28 from practice assignment 4. Now you guys have already done recursion last semester using Python, and with Java the logic is just the same. So let's have a quick overview on recursive methods. So a recursive method is a method which calls itself. Recursive methods are usually quite short and can solve a problem in a few lines. So if you find your method getting way too long, you're probably doing something wrong. Recursive methods are actually hidden loops themselves, so please do not use loops inside them. Doing that renders your method useless. Don't forget your anchor case, which is also known as a base case. An anchor case returns a value without making any more recursive calls. It is basically the condition that stops your recursive method from continuously executing. Now remember that you can have more than one anchor case depending on the problem you are trying to solve. Recursion memory is allocated using last in, first out, or LIFO. What does this mean? So recursion memory is allocated on something called a stack. LIFO means that data is added to the top of the stack when the method is executed, and that data is then removed from the top of the stack when the method exits. You will notice this in action in our tracing exercises as well as the other exercises we will do. Now, for those of you who aren't familiar with the compiler program I'm using, it's called IntelliJ. Don't worry about that and just continue working on JCreator. I'm only using this because I'm on my Mac. Try to have your compiler ready while watching this tutorial so you can practice the questions with me. Now, I'm assuming you guys haven't written any code in like 2 weeks, so let's do a quick warm-up on recursion before going on to our tutorial questions. I want to write a simple recursive method that counts down from any number I choose and prints out Happy New Year after it reaches 1. Sounds simple, right? So I'm going to make my method a static void one and have everything printed inside it instead of having the method return anything. So first we will begin with our method signature. So public static void countdown, and I will be giving it an integer. Now, since I want my recursive method to end after the countdown reaches 1, I will use if if x equals 0. This will be my anchor case, where Happy New Year will be printed once the countdown is done and it reaches 0. Remember that I do not want it to actually print 0. So if x equals 0, system.out.print Happy New Year. And this is our anchor case. Else. Otherwise, what is it that I want to do? I want to print out my number, and I want to call my function on the number less than it by 1. Do not forget your curly brackets. Here I will call my function countdown 10, and I will run. That's basically it. Now, after running the code, as you can see here, we get a countdown from 10, and it ends with Happy New Year. So this way, this recursive method works is as follows. So the number x is printed first, then the recursive method is called on the preceding number. This way the numbers are printed in the countdown order ending with Happy New Year. So here we have countdown 5, we'll print 5 and call countdown 4, print 4, call countdown 3, and so on and so forth until we reach countdown 0, which gives us Happy New Year. Now, what if I change something in the code? What if I switch these two statements? What would happen? Let's run. Here, I'm going in the opposite direction. First, it prints Happy New Year, and then it counts up from 1 to 10. So why did this happen? Well, this has to do with the stack. By switching these two statements, you basically continuously call the recursive method until you reach your anchor case. Only then does it begin printing the numbers, but in a last in, first out order. What will happen is Happy New Year will be printed out first, after all the recursion is done, and then 1 will be printed, and then 2 will be printed, and then 3, 4, 5, and so on, until you reach the original number the method was called for. Easy enough, right? Let's try another simple exercise. Do you guys remember how to calculate the factorial of a number? So 5 factorial is basically 5 times 4 times 3 times 2 times 1. How is this done recursively? It was done in the lecture, if you guys remember, but let me remind you guys quickly. So basically, if we look at 5 factorial, all we're doing is multiplying 5 by 4 factorial. Then to get 4 factorial, we are multiplying 4 by 3 factorial. To get 3 factorial, we're multiplying 3 by 2 factorial. And this goes on until we reach the end. So we are continuously multiplying the number we want to compute the factorial for by the factorial of its preceding number. Remember that mathematically speaking, in the final step, when we say 0 factorial is actually 1. So it's as if we're multiplying 1 times 1. This will be our anchor case. So once we reach 0, we will return 1. Now, let's write the code. So, public static double, because this time I'm going to be returning a double, factorial, and I will be giving it a double. Here is my anchor case. So if x is equal to 0, I will return 1. Else, I will return x multiplied by the factorial of the number preceding it, which is x minus 1. Now, if I want to call my function, and I will try to get a factorial of 5. Let's run. As you can see, we get 120. The factorial of 5 is 5 times 4 times 3 times 2 times 1, which is 120. So our answer in our method is correct. I hope this reminded you guys of how recursion works. Now let's look at our practice assignment questions. So, the first question we're going to look at is a tracing question. Take a look at this piece of code. We have our anchor case here, and then our method is called twice. Now pay attention to this sort of thing and take note of how the code behaves. So what would happen if we called mystery 348? Well, for starters, n would be equal to 348. And a would be equal to mystery 34, which is 348 divided by 10. Now this recursive part will be done first, before going on to b. This means we will continue with a until a value is returned. When mystery 34 is called, n is now 34, and a becomes mystery 3. Now, since n is less than 10, according to our base case, this method or function call will return 33. The value of b, on the other hand, becomes mystery 4, which will return 44. Put together, 100 times a plus b gives 3344. We then go back to our original function call and look at the value of b. Value of b calls mystery 8. And again, according to our base case, since 8 is less than 10, it will return 88. Putting the value we got from a with the new value of b and computing 100 times a plus b gives us 334488. Now let's run the code and see. Here is our code. Let's run it together. Note that A will be executed first and B will be executed last. As you can see, our result is 334488. What if we tried a different value for n? For example, how about 1569? As you can see, running our code gave us 11556699. So what does this code do? The code basically doubles each of the digits of any given integer n. Let's take a look at question 2. Write a recursive method, merge string sorted, that accepts two alphabetically sorted strings, S1 and S2 as parameters, and returns a new string that is alphabetically sorted and its content corresponds to a merge of both input strings. As you can see, the method signature is given with two parameters, S1 and S2, both of which are strings. The method itself should return a string. In other words, if S1 is ACE, and S2 is BDF, the recursive method should return A, B, C, D, E, F. So what are we trying to do? If we are given these two sorted strings, S1 and S2, and we want to merge S1 and S2 and sort them alphabetically. As you can see, both S1 and S2 have a length of 3. What we will do first is take a look at the first character of each string and compare them. The character which comes first alphabetically is taken, and the method is called on the remainder of the string from which it was taken and the entire second string. In this case, since A comes before B, we will take A and call the method on the remainder of the string, which is a substring of A from position 1, as well as all of S2. The first character of the remainder of S1 is compared to the first character of S2. Since B comes before C, it will be taken, and the method will be called on the remainder of the second string. This will continue until all characters are compared, meaning once the lengths of one or both strings become 0. This is what sets our anchor case. Now let's write the code. We will begin with the anchor case. So the first thing we will write will be our anchor case if s1.length is equal to 0 and s2.length is equal to 0, then in that case we'll return an empty string. We should also look at each string on its own. So if s1.length is equal to 0, therefore what we need to do here is return the remainder of S2. Else, if S2.length is equal to 0, then we will return S1. Now this helps us because what if the two strings aren't of the same length, specifically at some point throughout the recursion? Since both strings are sorted, it's safe to say that whatever is left of the longer string will be in alphabetical order and can be added to the sorted merged string. Now let's write the recursive part. In the recursive part, we are going to check if the first character inside S1 is less than the first character inside S2. See our use of char@ here? This basically compares the Unicode values of the two characters. Characters that come first in the alphabet have lower Unicode values. Therefore, in this case, we shall return the first character of S1 concatenated with our function call, or our recursive function. Now, what are we going to call our function for? What are the parameters going to be? Now, if we took the first character of S1, this means that we will call the remaining string after the first character has been removed from S1 and all of S2. the remaining string is basically a substring of S1 starting from position 1. So we will call it on S1 dot substring beginning position 1 and S2. Now what if S2 has the first character that is lesser in value than that of S1? What we will do is we will return the same thing, but instead with the first character, S2, plus merge string sorted, S1 as it is, and the substring of S2 starting from position 1. So this is basically our code. Let's run it and see what we get. As you can see, for each of the examples that were given, we have gotten exactly what we are looking for. So A, B, C, D, E, F gives A, B, C, D, E, F. A, C, D, X and A, B, Z give A, B, C, D, X, Z. X and A, B, Z give A, B, X, Z. Now in our final example here, you have AAB and CC, where you have capital A and small b, and capital C and small c. The answer is capital A, capital C, and then small a, small b, small c. Now why is that? This is because the Unicode values of uppercase letters differ from and are smaller than their lowercase counterparts. Consequently, you will get the output you see here. Now, here's a quick note. It's not a general rule, but sometimes when dealing with strings in recursion, the anchor case usually involves returning an empty string once the length of the string becomes 0, just as we did here. So this is a good thing to keep in mind. Let's take a look at question number 12. We would like to count the number of ears in a mutant bunny line, assuming that even-numbered mutant bunnies have 2 ears and odd-numbered mutant bunnies have 3 ears. Write a recursive method, mutant bunny ears, that given the number of mutant bunnies returns the number of ears of the bunnies. So what does this mean? Let's break down the question. This basically means every odd-numbered mutant bunny has 3 ears, and every even-numbered mutant bunny has 2 ears. So let's say we have 6 mutant bunnies. Our code should show that the 6th mutant bunny has 2 ears, the 5th mutant bunny has 3 ears, the 4th mutant bunny has 2 ears, and so on and so forth until we reach the 1st mutant bunny. All these ears should then be added together, and in this case, we get 15 ears. How do we think about this problem recursively? We will take the 6th bunny and check if it is even or odd numbered. If it is even numbered, we will add 2 ears, and if it is odd numbered, we will add 3 ears. We then call our method on the remaining bunnies. Once more, we check if the 5th bunny is even or odd numbered, add the respective number of ears, and call our method on the remaining bunnies. This goes on till the 1st bunny is reached, which is also the last bunny in the bunch. So what should happen once you reach this bunny? Your method should stop, making this your anchor case. There is no point in going on to the 0th bunny, because that bunny doesn't exist. So in a nutshell, what we are doing is checking whether the nth mutant bunny is even or odd numbered, and we call our method on n-1 mutant bunnies. Once we reach the last mutant bunny, meaning once n is equal to 1, we will return 3 ears, since 1 is an odd number. Now let's write the code. So, first thing we will write is our anchor case, where when x is equal to 1, we will return 3. Else, if it's an even numbered bunny, then we will return 2 plus, and we will call our recursive method. And we will pass n-1 bunnies, or in this case actually it's x-1 bunnies. We will then do the same thing for odd numbered bunnies, but instead we will return 3 plus mutant bunny ears x-1. So here we are adding 2 ears and call the function on the remaining bunnies, and here we're adding 3 ears and calling the function on the remaining bunnies. Now, if we run this code on 6 bunnies, like we previously said, we should get 15 ears. So what do we get when we run the code? As you can see, we get 15 ears. If we run the code for any number of bunnies, it will compute the number of ears in total. So if we try 20 bunnies, we will get 50 ears. Now, to help further explain the idea behind the code, here is a little illustration. Now this illustration will show how the memory is allocated on the stack for this recursive method. Now each time the method is called, it adds a number, 2 or 3, to the method call, right? So if we draw a tree of this, it would look like this. With each recursion, a new branch is made until we reach our anchor case. That is the first bunny, which has 3 ears. The values are then added, but going backwards. Remember, last in, first out, LIFO. So the last value is added first, and then the second, last, and then the one after that, and so on and so forth until the very end. So we will add 3 for the first bunny, 2 for the second bunny, 3 for the third bunny, 2 for the fourth bunny, 3 for the fifth bunny, and 2 for the sixth bunny. Now this is how stack works, and drawing trees like this can help you when you are tracing. Let's look at question number 22. This is another tracing question. Take a look at this code. What would we get if we called mystery and passed an empty string, CSIS, and the number 3? Let's trace the call. Note that within this recursive method, mystery is called twice. So I have colored one in black and one in blue. This way you can differentiate between them while we are doing our tracing. Now once the method is called, we see the first black mystery method. It passes the prefix plus the first character in the string remainder without the first character, and k-1. So the parameters are empty string plus first character, which is C, then SIS, which is remainder without the first character, and k-1, which is 3-1, giving us 2. Remember that the original prefix is the empty string, and the original k is 3. We will need those later. Note that these are passed into the mystery method as the prefix and k, respectively. The method is called once more, this time adding s to the prefix, and k becomes 1. Remember that the original prefix here is C, and the original k is 2. CS and 1 are passed as the prefix and k, respectively. Again, the method is called, where I is added to the prefix and k becomes 0. Remember that the original prefix and k in this recursion are CS and 1. CSI and 0 are passed as the prefix and k. And since k is 0, the prefix will be printed, and the prefix in this case is CSI. Now the blue method will be called using the original prefix and k, which were CS and 1. This then leads to the calling of the black mystery method, where the prefix passed is CSS and k is 0. This leads the prefix CSS to be printed. Now we go back a step. After the recursion of the previous black method has ended, the method in blue is called using the original prefix and k values, which in this case were C and 2. The black method is called leading the prefix CIS to be printed. We go back another step, where the blue method from the very first recursion is called with the original prefix and k of that recursion. Those were the empty string and 3. This consequently leads to the calling of the method in black until k becomes 0, thus leading the prefix SIS to be printed. In conclusion, the following should be printed out: CSI, CSS, CIS, and SIS, and they should be printed in that specific order. Let's run the code and see. Here we have our code. Here we have our 2 mystery methods. The first one being the black one, and the second one being the blue one. So if I run my code, as you can see, we got the same result as that of our tracing. So what does this code do? Let's try running it again, this time with a string potato and a k of 4. as you can see, the result shows different four-lettered combinations of the letters in the word or in the string potato. This basically means that the code gives all the different K-letter combinations for the string that you pass. And that is the functionality of this code. Write a recursive Java method, mergeRec, that takes two integers, x and y, and returns a new integer by alternating the digits of x and y. The digits should be alternated from the right to the left. Okay, let's see how this would work. Let's say I have two integers, 168 and 734. Please note that these are integers, not strings. Therefore, we need to manipulate the integers, and the way we do that is using integer division and modulus. I hope you guys remember how to use integer division and modulus, and I hope you guys remember that in Java, we do not have the double slash for integer division. In Java, we actually have just a single slash, and when you are given an integer and you're dividing by an integer, you're going to get an integer. And I hope you guys remember how to use modulus. Modulus gives you the remainder. So when you use integer division by 10 and modulus 10, in that case, what we are doing is we are trying to extract the digits from a number. Now, for our two integers, we want to take the rightmost digit of each integer. This is done using modulus 10. To get the remaining two digits on the left, we simply divide by 10. The rightmost digit of each remaining two digits is then extracted using modulus 10, and the remaining digit is extracted using division by 10. This continues until no digits are left, or the remaining number is 0. This is what defines our anchor case, that we end up with 0 at the end. As you can see here, what we're doing is we are calling our method on the remaining numbers after extracting the rightmost digit. So we keep calling the method on the remaining number on the left. So if we want to write this code, what is it that we would do? First, we can start with our base case. If n equals 0, then I will return m. As you can see here, our method signature shows that we are going to return an integer, and we are going to pass two integers as parameters. This shows you that you cannot use strings, that you have to manipulate the integers. So, our base case, if n is 0, then return m. Basically, once n becomes 0, return whatever is left of the integer m. And vice versa is true. If m becomes 0, we will return n. Else, here is where our recursive part comes in. Now, merge rec. What am I doing here? First off, I want to extract the rightmost digits of the two integers. So I will use m modulus 10 And I will also use n modulus 10. However, if I add n modulus 10 to m modulus 10, I'm basically adding the two digits. That's not what I want. So what I'm going to do is I'm going to multiply n modulus 10 by 10. This way, what happens is, if I have my two digits being 6 and 3, for example, I get 63 instead of getting 9. Now back to our code. Now let's look at our recursive part. Like I said, we need to divide by 10. So if I'm going to do n divided by 10, if I'm going to pass n divided by 10, these are the remaining digits on the left for n, and m divided by 10, the remaining digits on the left for m. If I pass those, then in that case, I should be done. So if I run my recursive function, which has an error somewhere for some reason, there we go. So now if I run this, oh, you see, here's my error. I didn't return anything. So yeah, now if I do it, look at the numbers I'm getting. So I gave 168734, and that's not what I got, something completely different. I don't even know what this number is. My mistake is that what I should do here is multiply by 100 to place the digits in their correct places. So once I multiply by 100 and I run again, this time it worked. So this time, as you can see, we're alternating from right to left. So 4, 8, 3, 6, 7, 1. Then 7, 1, then 6, 5. So you see here, this is where our base case came into play, because one number has less digits than the other. N has less digits than m. Consequently, when we are alternating, right after we alternated 7, 1, I just took on the rest, 6, 5. The same thing happened here. We have 4, 6, then 3, 8, and then we just took on the 7 and 1 at the end. 0 and 0 will give 0. 1, 2, 3 will give 1, 2, 3, and 1, 2, 3, and 0 will give 1, 2, 3. And this is how we manipulate integers in a recursive method. Again, guys, please remember, in exams or in assignments or whatever it is that you are faced with in life, if you are told to manipulate the integers, do not use strings. Using strings would have been so much easier. But using integers requires a bit more thought. In conclusion, I need you guys to pay attention to a few things when it comes to recursion. First off, no loops are used inside recursive functions. Again, I cannot stress this enough because I saw this being done when we were taking Python last semester. so please avoid doing this. Pay attention to the stack when tracing. Now the placement of the method matters, and it will determine what will be printed and how. Don't forget your anchor case. For strings, that is usually when the length of the string becomes 0. For numbers, it could be when the number reaches 0 or 1, depending on what your question is about. But in general, anchor cases are important. If you still haven't gotten the hang of recursion, remember that practice makes perfect. So practice, practice, practice. Try different questions. There are many questions on your practice assignment, so try to solve them. And if you get stumped or you get stuck anywhere, just send me an email and let me know. So that's it, you guys. That's the end of our tutorial. Thanks for watching and listening. This is my email for those of you that may have forgotten it. Again, I welcome emails all the time. If anybody has any questions, anybody's confused about anything, I'll be more than happy to answer you guys. Just stay safe, take care of yourselves, and good luck.